What are bibliometrics and what can they tell us? Bibliometrics originates from the French word bibliométrie, coined by Paul Otlet in 1934, and the word was anglicized as bibliometrics by Alan Pritchard later in 1969. It's a field of study that describes using mathematics and statistical methods to analyze publications like books, research papers, and articles. In this Venn diagram, you can see how bibliometrics fits into the larger field of informametrics, which looks at the quantitative aspects of information in general. There's a lot of overlap between the subfield of bibliometrics that studies any form of recorded information, like documents or books, and the subfield of scientometrics that quantifies aspects of scientific or scholarly literature. In this video series, we'll be focusing on the scientometrics perspective, looking specifically at research literature. As you may remember, Paul Otlet appeared to pioneer the field of bibliometrics. He's often called the father of information science, and he believed that books were an inadequate way of storing information. Individual facts or ideas can be difficult to locate in a book, and to Otlet, a better system seemed to be classifying and filing cards that have individual chunks of information to view an outline of the expanse of knowledge as a whole. And a great way to visualize these chunks of information and how they relate to one another is through the use of a network. In fact, a network that we use regularly, the World Wide Web, appears to have components that are derived from bibliometrics theory. Think about how an algorithm of a search engine like Google works. Each node would be a web page, which are sorted in terms of relevance based on a citation-driven model. And the hyperlinks between web pages represent the links or edges similar to those of a bibliometric network. The bibliometric networks can give us a big picture view of the intellectual structure of a field, where we can get an idea of major authors collaborating with each other, publications that have the most influence, or citations, and the evolution of an interconnected group of important themes or concepts. It allows us to map science. There are different types of networks you may come across in bibliometric network analyses. A co-occurrence or co-word network is a network of keywords found in the literature, like from titles, abstracts, and keywords listed by the authors that occur together. Each node represents a keyword. The bigger the node, the more times the keyword occurs in the corpus of literature. The stronger the links between the co-occurring keywords, the more times they have been cited together. Co-authorship networks display nodes of authors, organizations, or countries that have produced publications. Links between these nodes indicate collaborations between authors, and the bigger a node, the greater number of publications an author has. A citation network involves document nodes, and the links show one document citing another. These networks are often used to show the impact of a scholarly paper or author. A co-citation network shows links that depend on the frequency with which two documents are cited together by other documents. The more co-citations two documents have, the higher their co-citation strength. They're also said to be semantically related. Bibliographic coupling networks. If two publications are bibliographically coupled, they both cite one or more publications in common. The two works may have referenced a common work in their bibliographies. What are the statistics behind these networks of clustered bibliographic items? The statistics can vary based on the bibliometric software you use. A similarity index can be used to derive similarities between nodes and normalize data, so that the differences of links between nodes are accounted for. For instance, VosViewer uses a similarity index called association strength that's represented by the equation seen here. Some other indices include Salton's cosine, Jacquard's index, and equivalence index. So far, we've seen techniques used for science mapping. Another application of bibliometrics is performance analysis. It quantifies citation and publication metrics. You're able to gain a numerical sense of the most influential papers, the journals that have published the most papers, and the total number of publications overall and their distribution over time. Two popular matrices are the H-index and G-index. The H-index or Hirsch index evaluates the cumulative impact of an author's scholarly output and performance. The H-index corresponds to the maximum number of articles, say n, on a list of publications ranked in descending order by the time cited that have n or more citations. If somebody has an H-index of 4, it means that a maximum of 4 of their articles have been cited at least 4 times each. The G-index is an updated alternative to the older H-index. It averages the number of publications. In other words, it's the largest number, n, of highly cited articles, for which the average number of citations is at least n. Now that we have a basic understanding of bibliometrics and their networks, let's now look at how we can create them for our studies.